Hello, my name is Ryan, and I am the CityU DSC lead. Uh, CityU DSC stands for CityU Developer Student Club, and maybe some of you not knowing what is Developer Student Club. So DSC is kind of a community that with Google developers organization stuff, but mainly constructed by the students. So in our school, this is our first year to have this wonderful organization in our school, and I'm very glad to become a lead in this club. Okay, so this is a club, this is a community that we can find, we can gather the students, nice developers around, and we can develop together, and we can organize events together. This is a very nice opportunity for us. After talking about developer student clubs, I want to talk more about the CityU Developer Student Club. So you can see about us, we have currently we have 15 core members in our team, and we selected from more than 60 excellent developers in our school. So you can say that they're all elite and among CityU developers, student developers. And we are quite a variety group that we have experts from web development and some experts in app development, maybe iOS developer and also Android developer. And we also have a data team that who mainly expert as machine learning and also data science and also maybe some computer machine maybe computer how to say that image recognition, something like that. Yeah. And I'm sure that some of us has a lot of experiences on organizing events. There are quite a lot of talents. They have organized quite a lot of events before, and it's turned out really, really successful. Next, I want to talk about since we have only established for 2 months, but this is our first project for all of our members. We developed a DSC web for CityU. So you can see that their homepage and intro page and about our projects, events, what you have done, and what events are we going to hold. So we can put advertisement inside this web. Yeah. And next, this is another project that we have done in last month. So this is a Flutter COVID-19 app. So we have a team like 5 members. We're interested in Flutter, and we build these applications. So this is not just only beautiful. You can see that the figure is real-time data, real-time data of this COVID-19. So this project is for a small competition for the DSC summer boot camp, and eventually we won the first place of among the teams, and our we love this. Okay, another is the one called CityU Tech Hub. CityU Tech Hub is still work in progress. So this is not image of the CityU Tech Hub, but this is the image from CityU Apps Lab, which is another organization led by Dr. Ray as a very, very excellent organizations. And we hope to build a very big open source, like maybe some GitHub plus Stack Overflow website for CityU students inside our school. So the students can upload their code, can ask questions, coding questions on that CityU Tech Hub. And next, this is an ongoing event called City Hack. So City Hack is an annual event that CityU will hold every year, and mainly it organized by CityU IT team. But this year, it's our pleasure to co-host with them. So we will have a online City Hack maybe on semester B next year. So now we are called for sponsor, and of course, you want to become a judge of this hackathon events. Feel free to contact the CityU team, or feel free to contact me as well. Next, it's welcome. Welcome. Since we are open for any tech share, any career sharing, any hackathon sponsorship, or any IT workshop. We would like to organize with you. And I know that there's quite lots of talents here, and that will be a great chance for us to cooperate with each other. So this is the session for my team members, Eugene, and he's going to talk about a wonderful topic called, about the TypeScript. So now I'll pass the time to him. Eugene?
Okay. Hello. Yeah. So I'm Eugene. So in this talk, I will talk about how to automate your backend with backend schema with TypeScript classes. So I'm also a member from CityU Tech Hub, which is the one of the very good organization that I have in my final year. So I want to start with a typical scenario, like for a project, usually we have two developers, one in backend and then another one in front end. And then for backend, usually we have a language that's different from the front end. And in this example, I'm using a PHP backend example. The developer A have created a function called total cost, and they take in an invoice and output a float, which calculates the discount and service charge. And for the developer B, because you need to show the total cost as a UI components for the users, so usually we need to logically translate this function into a another same functions inside the front end. So to achieve a business logic, actually we're doing the same thing twice, and can we even sure that they are the same, right? And in this case, we are more likely to introduce some bugs that's is not even we don't even know. So how can we mitigate this? So the first thing we can attack this problem is from the language perspective. So we can use the same language and some kind of code generation. For example, if we use JavaScript, we can use JavaScript in both sides, backend and front end. And the second one is that we hire a full stack. That full stack will just do all the tasks from backend to front end. And the third one is that we can use a language-to-language transponder. The language-to-language transponder is not very reliable, and I don't think most people will trust the language-to-language transponder. And the last one is quite a funny one, as we can just tell the product manager that this is not possible. And this actually, as a developer, we have this kind of feeling quite a lot of time. Yeah. So what I want to do is to solve this problem in the architecture perspective, and we use an object-oriented approach with TypeScript. So because Node.js and NPM is now matured enough, and I think it has powered a lot of app in our backend as our favorite. So don't be scared of Node.js. So what we want to do here is that we want the least effort in our workflow. So developer can easily use auto-completion, the code generation, and they can follow the do not repeat yourself philosophy. So what we want is that we want to automate our schema and operation. Our schema is, as an example, is the data structure, and the operation is the business logic. So how can we automate it? So I want to start my talk with a timeline. So I'll start talking about TypeScript, and then eventually we'll talk about GraphQL and MongoDB. These two are very technical, but they are very useful tools for developers to build their backend. And then Type GraphQL and Typegoose is just to elevate the features of TypeScript to make it even more developer friendly. And then I will give a demo on all this. So TypeScript is a transpiler, which means it transpiles a language into JavaScript. There's a very famous quote by Jeff Atwood from 2007, which is like, any application can be written in JavaScript, will eventually be written in JavaScript. Actually, we have seen this in 2020. Desktop electron apps and hybrid apps, PWA in mobile is very famous now. But there's a problem, because vanilla JavaScript is prone to bugs. You can easily cause any bugs because you usually don't know what's the return type of some other functions. And TypeScript is not just strongly typed. The first thing I want to say is that all JavaScript is actually a part of a TypeScript. So your JavaScript can your TypeScript can be compiled into JavaScript easily. The second thing is all TypeScript is automatically documented, which means you can have a good developing experience. You can use auto-completion to automatically help you complete most of your code without actually spending too much effort thinking which variable to use. It's also easier for other developers. They can easily read your code and know what return types is coming, right? So for TypeScript, it's easy to compile into other into JS with 15% less bugs. This is shown by some studies. And you can use future JavaScript features that's not even yet released. Besides that, TypeScript also supports optional backward compatibility, which means that you can compile your TypeScript into ES5 or ES 2015 JavaScript at your choice. Right? So there are some features of TypeScript that spring into JavaScript. The first thing is that with interface, the interface and type. You can use interface and type with the interface and type keywords. And generics, which is a very popular object-oriented function. And then we also have the most important thing I want to talk about in this talk is the decorators. And decorators are, you can decorate anything inside TypeScript, like function, variable, parameters, and classes. And you can use the reflect metadata library to customize your decoration. So there's some tips I want to give about TypeScript. Like, as an example, to translate the TypeScript file into JavaScript, you can use the DSC command. And then, like in this example, you will be able to create an index.js file. The TypeScript config.ts is for you to configure which kind of how to output your JavaScript. You can compile into any version of JavaScript with this configuration. And to get a declaration of the types, you can use the add types prefix. For example, when you're installing the packages express, you can use add types /express to install the package for declaration of express. And the -d in this case is actually talking about to save this as a development only, so it will not be compiled into production. So you're still you're not expanding your code base size. So TypeScript, you can use a lot of auto-completion in TypeScript because all the types are clearly written. And if you're really not sure what type to use, just straight up use any. But I really don't recommend you to do this. So in my personal view, I think you should try to declare your types as much as possible because it gives other developers really good experience. And you should prefer utility types such as the partial, in which case you selectively select the subset of the variables in user class, and there's so many others. You should try to play with this type because it improves your software design skill and it lets you understand the underlying structure of these packages, right? So the second thing I want to talk about is the GraphQL. So GraphQL is a query language for your API. In this example is the query of a GraphQL. So it will automatically document and optimize your API for anyone to use. So they don't have to guess how your API works. So in this example, you can see that I'm getting a me in a ID, name, and friends. And for each friends, I want to get the ID and the names. Right? So graphical is the GUI for testing your API, so you don't have to use Postman and guess what is the URL of the particular API. And why do you need GraphQL? And I think it will reduce less time on documenting your own API and give the front-end developer more flexibility to design which kind of variables they want. Right? In the end, you can save bandwidth and with less queries. You can also concatenate different queries together into a single bigger query. So how to use GraphQL? The first thing is that you have two parts. The first one is the schema. For each schema, you will have the type of the, for example, in this case is the user class, and you can define the each fields. And for the resolvers, is each functions in is when you want, for which one you want to use. For example, in this case, I want to use the function me to get myself. Yeah. And also mutation will cause a permanent change in your database. So they actually are semantically different, but under the implementation is almost similar. The very special part of GraphQL is the highlighted weight, which you can actually query the nested information, for example, like a name of each of the friends. And this is not possible in traditional API. So one of the library, do you remember the TypeScript classes that we have used just now? For example, in this case, we have the class user, ID, name, and friends, and they are quite similar to the GraphQL schema, right? So what we should do is to try to automate this process of translating the TypeScript classes into our GraphQL schema. So we can use the library type GraphQL to do that. So first, we use the object type to decorate this particular class user to turn it into a schema of GraphQL. And we can use the add field to decorate each of the field. I will show this later to decorate those variables so that you can also selectively select which variable you don't want. For example, if you have like a session ID you don't want to expose this, you can just don't decorate it with add field. And add authorize can help you limit which field you want to show. So the second thing is that I want to talk about the resolver of GraphQL. As you remember, there's two parts of GraphQL. First one is the schema, second is the resolver. And for the resolver, each of our function inside that class will be actually automatically become the GraphQL functions. So if you tag it as a query, then it will become a query, and the mutation will become a mutation. And the field resolver in this case allow us to do the nested population like just now. Each of the friends we want is name and ID. We can use this. If we can use the field resolver decorator. And we can also use the authorized decorator to decorate these fields so that if you're not authorized, you can access this field. And you will ask about how do I get the some kind of information inside the request. You can use the add context decorator to get the request information and to modify your response data. For example, you want different response code. But there is still some limitation because this concept is still quite new. So field resolving is still not mature. For example, reflect metadata sometimes cannot decide what kind of output you are going. And you cannot create constructor for these classes because the type GraphQL will create their own constructor. But there is also some security concern, for example, extremely large query, but this can be easily detected. So the thing I'm going to say is the MongoDB. This is a very famous database. I think most of you are maybe even more have more knowledge on this. So MongoDB is a document-oriented database. It's more flexible and suitable for JavaScript application, and it saves spaces because you don't have to design the columns that you don't need. Besides that, it also closely resembles JavaScript objects, which means you don't have to spend time translating between both. But there is still some downsides. For example, it's harder to do joins, aggregation. Therefore, database design is extremely important. MongoDB Atlas is a free service, so you can try it. You can try it with GCP version. And the MongoDB Compass is a GUI for you to navigate between databases. You can create fields and do editing. For our cases, because we are talking about JavaScript and TypeScript, so we'll use a library called Mongoose. You can see that it has 1 billion downloads, so it's very famous, and it allows us to design and query the database. So Typegoose is actually a library that's helped us to do the similar thing like just now. We want to translate GraphQL query into TypeScript classes into GraphQL schemas. So we can also do the same thing with Typegoose. This one will help us to translate into Mongoose models. Mongoose models we can then insert into our databases according to the models. So there's a function in Mongoose Typegoose which is get model for classes. If you put in the class name, it will take in all the fields with decorated with prop and turn them into models. The best thing about Mongoose is that Typegoose is that you are able to use the TypeScript abstraction, which means inheritance and more features. I will show it more later. So we can also use Mongoose features from Typegoose. And the most important thing is that when we are querying the database, we get back the type, so we don't have to guess what kind of values are inside the query that we've done. So I want to talk a bit more about the software design. So as a scenario of the TypeScript abstraction. So at first, we can create a base class. In this base class, it can have like ID, last updated date, the deleted date, and the created date. By using the Mongoose feature, we can create a feature that soft delete by default. And then we can filter the deleted result on every single search, right? So upon saving, you can also save the last updated date. So there's still a lot of more Mongoose feature we can add. But it's not just constrained between this base class. If we extend the user class onto this base class, all the features inside the base class will be moved to user class 2. So this is quite a different paradigm that we can see, right? And this will help us keep the dry philosophy, which is do not repeat yourself. I repeat myself again. Yeah. So I will talk a bit more about the demo I'm going to show later, which is the architecture of I'm going to show later with Angular as an example. So our backend will start with a Node.js server. Node.js is a JavaScript compiler, I could say. Yeah. So we can use the Express server as on top of this Node.js and then a Apollo server. The Apollo server is just to help us to connect between different front end services. And if we look at the front end, we'll have a Angular at the start and then a Apollo service on top of it. So this will help. So these two Apollo services will communicate with GraphQL. And then we can use a code generation tool to automatically generate a schema that is similar to our backend. This schema is a shadow schema. We didn't write this ourselves because it's automatically generated. And we can use this schema throughout our front-end apps. And it will be similar but not the same to our backend because we have some fields that we don't want to show the user filtered out, right? So later, for the backend, there's also schema and resolvers, which is the requirements for the GraphQL to operate. And for each of the Angular, we can create a services that uses the utility module. This utility module can store the code that we started earlier. Do you remember like the problem that we stated at the first? 2 different languages, different implementation, and then we are not even sure if they are the same. We can put them together into a single file. They can be shared between different services, backend and frontend. But if there's really private functions that you don't want to show to the front end, you can keep them in resolvers. So in this way, then our information will not be shown to the others. And at last, we'll have a UI that uses the service to show to the user, right? So I will show my demo. So at the start, in this project, we have few folders. You can see the Angular app is inside the web. Okay. So we'll start with a schema. This schema is a TypeScript file. It will be turned into a JavaScript. It will be turned into a GraphQL schema and the Mongoose models later, right? So we start with a add object type decorator. This decorator will decorate this class into the TypeScript, into the GraphQL schema. The add field decorator will decorate the variable so that it can be shown to the on the GraphQL schema. I will show it later. So an add prop is for Mongoose so that we can save it into a database. So we can use Mongoose features such as these two to automatically do the last update and to filter the deleted. If we look at the user, we can just directly extend the base class and all the features of the base class will be moved to the user. So I want you to notice that there's no ID and last updated date and all this information inside the user class, but it will automatically reflect later, right? And there's also some fields that we don't want to show to the user. For example, the hash password. So in this case, we just don't decorate it with add field. So the second part of the GraphQL is the resolver, as we said. For the resolver, we start from a decorator of the resolver for the class user resolver. So all the functions inside this class will become the functions for GraphQL. For user, for example, like we have a query resolver. So in this case, as long as I will use the name user, then if I provide the ID, then I will get back a user schema. So there's also mutation with variables. And the last one I want to show is that, for example, let's say there's a bug here. We can see that the type color is not trying to accept this string or undefined. If you take a look at this input, we can see that actually we are optionally selecting this color. So how can we fix this? In that case, actually TypeScript have helped us catch a bug, right? So we can add a if statement to check if the user input with auto completion to check if the input is correct. Then it will and then this one will fix our problem. So I want to kind of show the graphical, just now the GraphQL GUI for us to use. So in this example, for example, we have a query, we can query users and we get the ID, name, and all the name of the friends of these users. Let's take a look at the schema. So for the schema, we can see that just now, although we did not state these fields, it's automatically put inside the user because of abstraction, right? And for our documentation, it's also automatically documented. Inside the user, let's say we can just provide an ID and we'll know what is the return type of this user with this information. And for each friends, we can also see that what's the return type of the friends. Let's try to run this function. And in here, we can see that although we did not specify how to find friends for TypeScript inside the TypeScript with the field resolver, we're able to automatically find the friends of the information of the friends of that particular user. Okay, the next thing I want to talk about is the Angular part. So how can we use this API? So we can create a file called chat.graphql in this case. So this syntax is similar to the syntax here. For example, I want to get all the chats, and for each of the order, I want to get the name, the ID, and the color, right? So if you look at the UI, you can think about it as I sign in inside here, and then for each of the user, there's a chat, and then with name, name and color, and then the text. So in that case, this is our query. But how can we use this query inside Angular? So in that case, we can use a code generator. For example, here, let's say I just run this automatic for this to automatically generate the code for us, and the code is generated inside this file. We can see that there is the similar query inside here, and it automatically creates a chats GraphQL Angular service, which we can use inside our application. So in here, actually, I did not do any effort in trying to connect backend and front end, except this GraphQL query. And then if we come back to here, we can import this chats GraphQL query, and then we can just fetch it and do some kind of operations, whatever we want. But let's try our app. Let's say I want to say welcome GDG. Oh, but it seems like there are some bugs in our application. It's showing the sad face, although I type in the smiley face, right? So if I get back, I can take a look. Okay, someone just left this to do here and say we need to fix the emoji filter function. It seems like this function have problems. Let's take a look. If you take a look here, we can see that it's actually importing from a utility folder that's outside of our original, it's outside of the Angular apps itself. So I think this person want to name this as replace emoji and want to replace all this smiley face into this. So actually what we can do, we can just right click and rename symbol. It takes some time to load here. Replace emoji, right? And then we can just like simply replace this emoji. And we can see that actually our Angular component automatically have the change. If we go and look, oh, it's changed. So this is a very good developer experience. We can rename anything we want inside the app because all the relationship is clear. So let me test this. So if I go back to front end, it automatically changed into smiley face. So let's try. Yeah, so it's a smiley face. So in that case, I've solved this bug and can just go with it. Done. Okay, so this actually just all I want to show for the demo. Yeah. So the take-home message I want here is that TypeScript, I think, is quite mature for modern system, and it can seriously speed up your application, right? And we have already have a very mature software design knowledge in our hand so many years. So we should actually take in this object-oriented approach in lots of application, and try not to repeat yourself. Use libraries such as Typegoose and TypeGraphQL or code generator to automatically generate and do most of the tasks for yourself, so you can easily focus on what's important. And the last is to be creative and open to new ideas, such as try a new library on all this. So this is the end of my talk. So if you have any question, you can ask me, and this is my GitHub QR code.
So if you have any question, you could ask in the YouTube comments. I think some of them may have question. I also have one too, but maybe wait a minute. Some of them is
Okay, thank you.
typing. maybe I ask my question first. I can see you have used the Express.js and with the Apollo. Yeah, so because I haven't touched the Angular before, but I have working on some React project using Express and Next.js. So is
Next.js, yeah.
Apollo is the same level, like just like the Next.js, but is for the TypeScript or for the
yeah. So like the Apollo is actually like a connector for different front end. For example, let's say I have React, Angular, I have so many different apps, but how do they use GraphQL, right? GraphQL is not like just a random thing you have to pass it, let's say. So the Apollo is some kind like a connector so that it reads. It helps you connect with another Apollo server so that these two can communicate. So actually Next.js is something very similar to the thing I'm saying here. But if you are the Express people, I'm not so sure if you will just jump ship to Next.js so fast because they are quite complex. There's a lot of things going on. Yeah.
Okay, so because the Next.js
I think it's a very good question.
can work with the Express, so Apollo is also can work with the Express.js well, and is have do some optimize or have some useful features function for the GraphQL, right?
Yeah. Seems like people are not asking questions.
There is a question from someone. They have direct message me. Someone want to ask, JS convert to TypeScript. In your experience, any issue that need to modify a lot after convert?
Can you repeat? Sorry, I can't hear.
Ask about JS convert to TypeScript. In your experience, any issue that need to modify a lot after convert? I can type.
So as an example, I think you are working on some kind of JavaScript apps and you want to convert into TypeScript. So I think for that case, for most of the time, as long as you just port the whole app, you just change the extension, it works directly, perfectly. But actually what you want is more, what you want in TypeScript is more than just JavaScript. You want type hinting. That's the most important thing, right? Because type hinting helps you develop faster later. You can just tap through most of the code, right? So I think there's no problem for converting from JavaScript to TypeScript. You can install more libraries and npm package with the add types prefix, and then but I would recommend you, if you have classes and all those things, try to document them and try to use the TypeScript hinting. Yeah, so that is the most important thing for TypeScript.
I'm also in my workspace. I'm also experienced converting a JS project to the TypeScript. There is some tools to do it, and but if for big project, the tool cannot do all for you. You may still need to fix some error, or if the project is a bit large, you may need to add some maybe ignore some TypeScript check for some file first, because many errors, hundreds error, but the tools should be able to fix most, but some you need to fix by yourself. But its work is still can run, so you could try, but try to convert to TypeScript at the early stage.
Yeah, try to convert to TypeScript early. I agree with this.
And you start your next project, choose TypeScript. More libraries already support TypeScript.
Yeah.
I think it's a trend.
Yeah, it's a trend. I think eventually all apps will be written in TypeScript.
Yeah, so just try it. Yeah, we will be with you. We are also trying the TypeScript. So maybe can go to the next session. If you have a question, you could leave in the YouTube comment or direct message to Eugene. And so the next, yes, and then thank you, Eugene.